The Milky Way may not be facing the direction in which it was born. That sounds almost impossible. Earth, the Sun, and every familiar constellation are carried inside a giant rotating disk of stars. To us, that disk feels like the permanent floor of the night sky. But a new line of research suggests the visible Milky Way may sit at a dramatic angle compared with the larger invisible structure around it. Not because the galaxy flipped like a coin. Galaxies do not move that way. The idea is slower, stranger, and much more interesting. Billions of years ago, when the Milky Way was still young, a smaller galaxy may have crashed into it. Over hundreds of millions of years, gravity may have tugged, twisted, and reoriented the system until the disk we live in was no longer aligned with part of its original dark matter halo. So the question is, how could an entire galaxy, containing hundreds of billions of stars, change its orientation? First, the Milky Way is not just the bright band we see from dark places on Earth. That bright band is the stellar disk, a flattened wheel of stars, gas, dust, and spiral structure. Near the middle is the central bulge, a crowded region packed with old stars. Around the disk is a faint stellar halo, where scattered ancient stars move on wider, stranger paths. Far beyond that is the dark matter halo, an enormous invisible structure inferred from gravity. Dark matter is not photographed directly. Researchers map it by measuring what it does. Stars move too fast. Satellite galaxies orbit in patterns. Streams of torn-apart stars curve through space. From those motions, astronomers infer where hidden mass must be. And that is where the weird part begins. One recent study argues that the Milky Way's outer dark matter halo may be oriented almost vertically compared with the disk. In a simple picture, imagine a bright spinning plate sitting inside a much larger invisible frame. You would expect the plate and the frame to point in roughly the same direction, but the evidence may suggest something more like a plate sitting sideways inside the larger structure. If that interpretation is right, it could be a fossil clue. The galaxy's dark halo may preserve a memory of an ancient event that the visible disk has partly moved away from. The leading suspect is a long-dead dwarf galaxy, often called Gaia sausage Enceladus. The name is strange, but the evidence is serious. Data from the European Space Agency's Gaia mission revealed many stars in the Milky Way halo moving on stretched, radial orbits, as if they came from a smaller galaxy that plunged into the early Milky Way. This was not a tiny pebble hitting a windshield. A dwarf galaxy is small only compared with a giant galaxy. On human scales, it is unimaginable. It may have carried billions of stars, gas, and its own dark matter. When it merged with the young Milky Way, it helped build part of the stellar halo and disturbed the galaxy's early structure. But could one collision really turn a galaxy? Only if we stop picturing the Milky Way as a solid object. It is not a rigid plate. It is a gravitational system. Stars, gas, dust, dark matter, and satellite galaxies all pulling on one another. If a spinning plate is struck off-center, it wobbles. If a gyroscope is torqued for long enough, its direction changes. A galaxy is looser and slower than either one, but gravity can still redirect it over deep time. Computer simulations show that galaxy mergers can create large, slow changes in orientation. A massive incoming system can drag on the dark halo, tilt the disk, stir the stellar halo, and leave behind streams of stars on unusual orbits. The result is not instant destruction. It is a long gravitational negotiation. This is why the word flipped needs care. Nobody watched the Milky Way suddenly rotate. Scientists did not see a clean before and after video. They measure today's motions, compare the visible disk with inferred dark matter, and test whether simulations can reproduce similar structures. The evidence suggests a story. It doesn't close the case. Some claims are directly observed or measured. Gaia has measured stellar positions and motions with extraordinary precision. Astronomers have found chemical and orbital signatures of ancient merger debris. They can trace stellar streams and compare the motion of halo stars with the disk. Other claims are inferred. The shape and orientation of the dark matter halo must be reconstructed from gravity's effects. The idea that the disk used to point a different way is a historical interpretation of today's structure. And some claims are modeled. Simulations can show that mergers like Gaia sausage Enceladus might reorient a disk or halo. But a simulation is not footage. It is a tested possibility, not a time machine. If this interpretation is correct, it changes how we think about our home galaxy. The Milky Way is often drawn as a calm spiral, almost like a cosmic island, but it may be more like an old crime scene. The stars around us could be arranged inside a galaxy still carrying the scar of a collision that happened before the sun existed. It could also change how astronomers read the satellite galaxies around the Milky Way. If the outer halo remembers a different orientation, then some satellite alignments may be clues to the old structure, not just random decoration. It may affect how scientists interpret stellar motions, dark matter models, and the timeline of the galaxy's growth. Still, there are big uncertainties. The exact angle is debated. The timing is not nailed down to a single moment. Gaia's sausage Enceladus may not be the only culprit. Several interactions could have contributed. The Milky Way has eaten smaller systems before, and it is still surrounded by satellites and streams. The outer halo is difficult to measure, and different models can tell different stories. So the most responsible version is not, a collision definitely flipped the Milky Way. It is this. Researchers have found evidence that the visible disk and the outer dark matter halo may be dramatically misaligned, and one proposed explanation is that an ancient merger slowly reoriented part of the galaxy. That is still astonishing, because every night sky we have ever known may be sitting inside the aftermath of a cosmic turning point. The constellations look fixed. The Milky Way looks like a steady river of light, but the galaxy carrying every star we see may still be wearing the scars of the moment it was turned toward a completely new direction. Subscribe to Curious Outpost for more big mysteries told through simple drawings.